Hello friends, today I'm going to solve LeetCode problem number 438, find all anagrams in a string. So in this problem we are given two strings S and P, and we need to return an array of all the start indices where we could find the anagrams of P in S. So what's an anagram? It's basically a permutation of the string P in string S. So that means the characters in the string P could be rearranged in any order in the string S, and that would be the anagram of string P. So let's look at this example here. So what do we have here? The string P is ABC and the string S has these characters, right? So now let's find the anagram of P. What would be the anagram of P? So basically we have ABC, and it would be any arrangement of these three characters. So it could be B, A, C, it could be C, B, A, and so on, right? So let's see, do we have any of these three characters that are together in the string S? Well, yes, of course we have one character, one here, anagram here, which starts at index 0, and the next one is at here at this index, so that's at index 6 if you would count 0 1 2 3 4 5 and 6, right? So that's what our answer is. Our answer would be an array which consists of values 0 and 6. So this is our answer. So that's all we have to do. So if you have done the LeetCode daily challenge of February 4, then you would know that this problem is quite a similar problem, but the difference is that we have to find the array of the starting indices. But in the LeetCode daily challenge on February 4, we just had to find if the permutation or the anagram exists or not. So quite the same problem, quite the same process, just the difference is we need to create an array. So what are we going to do is we are going to use sliding window with 2 pointers. So and we are also going to use a map to store the number of characters in the string S. So basically the frequency of the characters in string S. So what we're going to do is we are going to use a sliding window of length that will be equals to the length of the string P. So that would be equals to 3 for now, and then we start the 2 pointers, that is our left and right pointer would be at this index here. And then what do we do is we check if this character is in this string P, then we are going to increase the index R, the value for index R, which will point at in B, character B, and our count will keep a count. Okay, so you count, and will increase the value from 0 to 1. So this means that we have found one character for our string P that would be an anagram. And now we move to the next character and found the character B, which is also present in the string P. So we increase the count by 1, which becomes equals to 2, and then we increase the index of R, and now our R is at index A, pointing to A, and since A is also present in the string P, so we got our count value, which is equals to 3, that is equals to the length of P. So now what do is we note that we found a permutation, an anagram, and then we push the value of L to our result. So our result, we have the value 0 here. Now what we do next is our index L is at index 0, our index R is at index 2 right now, which is pointing to character A, and we increment the value of R. Now the value of R is equals to 3, and since the difference between these two characters is equals to 3, which means that there are 4 characters now in this window. So what do we need to do is we need to shorten the window size, that is to create only the window size of 3. So we will increase the value of index L. So now L will point to index 1. So now L will point to index 1, and then we will have a window of size equals to 3, from 1 to 3 inclusive. So in that way we keep on moving, and if we find this value, the count equals to 3, then we are going to push the value of L to our resulting array, and we reset the value of count every time the length of the sliding window becomes greater than 3. So now that we know how we need to solve this problem, let's actually solve this problem. So first of all, we are going to create a map. Okay, so we'll create map for our character, for all the characters at string p. So map, okay, I'm going to use not this but string literals. So if map c is equals to, if map c is present, that we are going to use that value, else we are using 0 and increment it by 1. Now that we have our map, what are we going to do is we are going to use a while loop. While okay, before that let's define our left and right pointer, and the count equals to 0, and our result array. Okay, and our while we will loop until the right pointer is less than the length of the string, because we are incrementing the right pointer every time, and left pointer will always be less than or equals to r. So we need to check if the right pointer is less than the length of the string s, right? So that's what we are doing here, and we are going to check if the character in our right index at string s is present in the map. That is, if it's greater than 0, then we are going to increment the count, and every time we are going to decrease the value of the character in the map, and we are going to increment the value of our right index. And we are going to check if the value of count is equals to the length of the string p, then we are going to push to our result the value of L, index L. And also if L minus R equals to 3, that is, if the sliding window is greater than 3, then we need to reduce the size, right? Not 3, actually it's the size of the string p. Then we are going to reduce the size of the sliding window. That is, we need to increment the value of L. We also need to reset the count. So we need to reset the count if we use that, okay, greater than equals to 0. If that character was used to change the value of count, if that character changed the value of count, that is when we are going to use to reset our count. All right, and yeah, we also need to increment the value of the map. Now that we have this thing, finally we are going to return our result. Now let's try to run our code. Okay, what's wrong here? Okay, sorry, this is not left minus right, right minus left, because left is always less than the right in x. All right, let's submit this solution now. Great. So let's look at the time complexity. So this will take, let's assume that the length of string s is m and p is n. So this would take O of n time complexity, and the while loop here, since we are looping over the length of the string s, so that would be O of m. So the total time complexity is O of m plus n, and the space complexity is constant, because even though we are using a map, the maximum length of the map can only be equals to 26. That is the length of the English alphabets, right? So that would be constant.